Okay, my dear students, now let us start with the second question. The second question is x of t, x, x of t is equal to 2j here. Now, as you can see, this signal involves an imaginary part here, means this is a complex signal here, okay? So we already knew the formula in the previous question that it's energy is equal to integration from minus infinity up to positive infinity. We have x of t, basically I'm using this x of t magnitude square dt here. So let me calculate this part separately here, okay? So we already know that from your previous courses, you should have studied it. We said that, for example, x is my complex signal, which we can write it as a plus b j here. It means this is a real part here, and this b is imaginary part here, okay? So now to find the magnitude here, so x here will be equal to my real part square plus the imaginary part square whole square root here. And since we are interested in finding the square here, so basically what we can have, like if we put a square here, the square root will be cancelled out here. Okay, so in our case, x is equal to 2j. So I can write it as like 0 plus 2j here. So it means my real part here is 0, imaginary part is 2 here. So the magnitude square will be equal to my imaginary part square, which is 2 square, which will be equal to 4 here. So I can substitute this thing directly here. Okay, and proceed here. So now the things are very simple. What we have here, basically we have integration from minus infinity up till positive infinity. We have 4dj here. Okay, so 4 is a constant, 4 can go outside here. So we will get basically t from minus infinity to the positive infinity, which is going to give us the infinite here. So basically my energy here is infinite here. Okay, so energy is infinite here. So now let's, as we discussed previously, so the possibility is either my power is going to be finite or infinite. If it is a finite, then obviously it is a power signal, and if it is infinite, then my signal is going to be neither, means neither energy nor power here. So power was equal to basically uh, limit t tends till infinity here, 1 over 2t here, integration from minus infinity to positive infinity here, and we have basically the same x of t here. Basically let me write the x like this, magnitude square dt. Okay, so I think I have written correctly, yes. Okay, so now as previously, this thing which we already previously calculated here, and we got 4 here, and the integration was t here. So we will be using the same concept here, but instead, sorry, I make small mistake here. It is not minus infinity, it is basically the capital T and the small minus t here. Okay, so please. So as previously, what we did here basically, uh, we can have minus infinity to infinity. So instead of minus infinity to infinity, we can have t and minus t here. So basically, mm, I will be having limit t tends to infinity 1 over 2t here. Okay, so the integration will give me t. So I am going to have like 4 from the same part here, and it will be like t minus t up to capital T here. Okay, so what we can have further basically, okay, let me keep it same here. So I say limit t tends to infinity here. This will be like 4 divided by 4 divided by 2t here, and the integration will give me basically t minus t here. So we know that this part will be equal to 2t here. Okay, so we are going to get limit t tends to infinity. We have basically 4 divided by 2t here, and it will be equal to 2 capital T here. So 2t will cancel out, and I will get 4 here. The 4 don't have any variable here, so it means this will be only 4 here. So basically what we got infinite energy here, and we got a finite power here. Finite power. So it means this is a power. Let me write here. This is a power signal here. Okay. Thank you.